Today we're going to multiply and divide rational expressions. There's two main types of problems that you're going to see. The first type is monomials, where you have a monomial in each numerator and a monomial in each denominator. That means just one term, like no addition and subtraction connecting terms together. So do you see how in B you got 3 plus 4x in the denominator? In A, there's no addition or subtraction anywhere. If you see problems like this that have addition and subtraction in the numerator and denominators, your goal is going to be factor everything and then see what cancels. If you don't have any addition or subtraction, like this first problem, your goal is to multiply the numerators together to get one numerator, multiply the denominators together to get one denominator, and then work on simplifying. So let's do that. If we're multiplying, combining this entire this entire numerator together, 4 times negative 6 is negative 24. X to the third times x squared. What is x to the third times x squared? X to the fifth. And y times y squared is y to the third. On the bottom, 3 times 10 is 30. X times x to the fourth is x to the fifth. And we have y to the fourth. The most common mistake I see in the next part is simplifying this fraction. Some people try to use properties of exponents to simplify this fraction, and I want you to note that this is a normal fraction. If you were going to put this in your calculator, it is negative 24 divided by 30. Simplify that fraction. So you can simplify this in your calculator if you want, or you can simplify this like the old way where you think about what could you divide out of both negative 24 and 30. You can divide them both by 6. Negative 24 divided by 6 is negative 4. 30 divided by 6 is 5. So the fraction negative 24 thirtieths simplifies to the fraction negative 4 fifths. What do you notice about the x's? They're the same, so they cancel. And in my experience, a lot of you don't like negative exponents. So the most mathematically correct way to do this problem is to say that you would subtract these exponents and get y to the negative 1 on top, and then that would move to the bottom. The easier way to think of it is you have y to the third on top, that's 3 of them. You have y to the fourth on the bottom, that's 4 of them. These 3 cancel out these 3. What do you have left? A y on the bottom. So think of it as the 3 on the top cancel out 3 of the 4 on the bottom, leaving 1 left over on the bottom. And that's your answer, negative 4 over 5y. Okay, in part B, this book in particular really likes to put things in the wrong order. Do you see anything in this problem that looks wrong?
Negative 4.
The next problem.
Oh.
3 plus 4x. How are we used to seeing that? 4x plus 3. Anytime you see an expression in a numerator or a denominator that's not in the correct order, we like to see the x's first and then the number. I want you to rearrange it. You can rearrange this numerator as long as you keep the 4x positive, because that plus goes with your 4x. So I'm going to rewrite this. 8 over 4x plus 3. Same thing with this 9 plus 12x. I'm going to write 12x plus 9. And this doesn't have a denominator. That means the denominator is 1. When you see addition or subtraction in the numerators and denominators, you want to try to factor anything that can possibly be factored. So the 8 can't really do much with the 8. But can we factor 12x plus 9? What do those two terms have in common? That's right, they have 3 in common. 12x divided by 3 is 4x. 9 divided by 3 is 3. This 4x plus 3 just becomes a 4x plus 3 on the bottom. And technically we have a times 1 down there, but do we really need the 1? Not really. All right, what cancels? 4x plus 3. What's left? 8 times 3 is 24. 24 over 1, or just 24. All right, let's look at example 1. Again, this one has one spot that I don't like. This thing right here is not in the correct order. So you can even do this right at the problem. This is negative 2x plus 3. See how there was a minus in between, and that minus attaches to the 2x. So it's negative 2x plus 3. Then what I notice is negative 2x plus 3 is kind of similar to this one. Is there any way we could make it look exactly like that one? If we pulled a negative 1 out, negative 2x divided by negative 1 is positive 2x. 3 divided by negative 1 is negative 3. That's really the only part of this problem that needed to be factored. So we now have on the top 2x minus 3, x plus 4, and 9x squared. On the bottom, we have negative 1 times 2x minus 3, and there's an x to the 4th in there. I just put the x to the 4th at the end instead of at the beginning. Doesn't matter where it is in the denominator as long as it's in the denominator. Okay, now, what cancels? 2x minus 3. Anything else? This x squared will cancel out 2 of these, leaving 2 left. So on the top, we have 9 times the quantity x plus 4. On the bottom, we still have x squared. This negative 1 is tricky. If you have one factor of negative 1 somewhere in the fraction, it doesn't matter where it is. It can be on the top, it can be on the bottom, it does not matter. It's best to just stick it on the top. Okay, personally, I like example B the best. This is my favorite kind of problem. This is the kind of problem where you factor, 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 cancel, 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 cancel. So I like to draw a nice big fraction bar and then start factoring. This first one, we are looking for 2 numbers that multiply to give us 4. Those same numbers have to add up to 5. What numbers do that? And the nice thing about these problems, when you have to factor, it's usually really small numbers, so it's fairly easy to factor. So that one becomes x plus 1, x plus 4. Next, we have x squared minus 9. How does x squared minus 9 factor? The difference of 2 squares, so it becomes x plus 3, x minus 3. The x plus 3, that can't be factored, so that's a factor of x plus 3. And then x squared plus 2x plus 1, looking for 2 numbers that multiply to give us 1 and add up to 2. Definitely 1 and 1, so x plus 1, x plus 1. Now we get to play the cancel game. What matches, what cancels? X plus 1 cancels out one of the x plus 1s. X plus 3 cancels x plus 3. So our final answer is x plus 4, x minus 3 over x plus 1. The only difference in example 2 is how to factor a trinomial when you have a number in front of the first term. Remember, you have to multiply that number in front with the last number before you figure out the pair of numbers. You use that pair of numbers to split this into 4 terms. You take that negative t and split it into 5t and negative 6t, then factor by grouping. If you need help with this, see me sometime and I will go through it with you and help you if you run into a problem like this. Let's move into division. Basically, the rule is that we don't divide. You should never actually divide. Instead, we multiply by the reciprocal. And I think you've heard this phrase before, keep, change, flip. That means keep the first fraction the same, change the sign to multiply, flip the second fraction. You're multiplying by the reciprocal, and reciprocal means flip. So in example 3, we would start by keeping the first fraction the same, change the sign to multiply, and flip the second fraction. So first we do KCF, keep, change, flip. Then you're going to want to factor everything that you possibly can. So pause the video if you're watching the video, try factoring all of these and canceling. If you're in class, just try. So, okay, once you have this all factored, now you get to start canceling things out. What cancels? X minus 2, x minus 4. Anything else? This x with the 2 will cancel out this x on the bottom. It's not 2x, it's actually 2 times x. So what's left? 2/3. I love this problem because you start with something super complex and then you do some math and it ends up being 2/3. And it's like, look at all that stuff I did and I got 2/3 as an answer. Am I the only one that thinks that's cool? Okay, it's cool. I'm a nerd, that's cool. All right, if you try example 4 on your own and want to check your answer, I will have the answer. I'll show it up here on the video in a minute. Otherwise, you can start working on your assignment.